Good evening. Hello, everyone, and welcome to the National Museum of the American Indians teacher webinar, Mayan Astronomy and Mathematics, yesterday and today. Thank you so much for joining us. I'm Renee Goki, and I'm the Teacher Services Coordinator at Nmei and also a citizen of the Eastern Shawnee Tribe. I want to get started by, of course, mentioning a land acknowledgement and the Native peoples on whose lands that we gather, the ancestral homelands, as well as the diverse and vibrant Native communities who make their homes here and in your home today. So this is a really important first step in creating continuous collaborative relationships with Native people that are still living, and also to take a moment to pause and think reflectively about what that means that we are living on lands that have been stewarded by Indigenous peoples throughout the Americas for thousands of years. So I want to take a moment to do that. Feel free to put in the chat if you do a land acknowledgement, and my colleague Bert Correa will actually include a land acknowledgement guide to get you started if it's a practice that you wish to bring into your own classroom or school. Next, I want to show pictures of our Nmei locations. So the National Museum of the American Indian is part of the Smithsonian Institution. We have 3 facilities. First, the DC facility that you see pictured on the left. This is our flagship museum, opened in 2004, September 21st. And we have an array of exciting programs and exhibitions, many of which are now available online for you. So please do check out our website. And when we open again, please come visit us in Washington, DC. In the middle, we have our Nmei Nmei New York in Lower Manhattan. And this is an excellent space again for exhibitions and a wonderful place to visit if you have the opportunity. Finally, our Cultural Resources Center is really the heart of the work that we do at the museum. This houses our 800,000 plus collection of ancestral objects, cultural objects that we consider ourselves stewards of and that we take care of. And so I want to acknowledge the Cultural Resources Center in Suitland, Maryland. Next, I want to tell you a little bit about the vision and mission of Nmei. Our mission is in partnership always with Native peoples and our allies, including you as teachers. The National Museum of the American Indian works to foster a richer shared human experience through a more informed understanding of Native peoples. We do this through many ways, one of which is our National Education Initiative. Secondly, our vision is equity and social justice for the Native peoples of the Western Hemisphere through education, inspiration, and empowerment. By being here as part of the workshop, you as teachers are contributing to not only this newly adopted vision of Nmei, but you're also part of our National Education Initiative called Native Knowledge 360, or NK 360 for short, which seeks to transform teaching and learning about American Indians and the Indigenous peoples of the Americas. So we're so pleased that you're here with us tonight. We also have our essential understandings, and this document is really a framework for understanding Native people and creates, as part of our National NK 360 program, really a framework and benchmarks for understanding and teaching about American Indians. This was created out of a textbook study that we conducted to see where Native people were covered in the curricula. And this tool is developed, this framework, around the 10 themes of the National Council for Social Studies. So this again provides language and key concepts that can act as benchmarks for your own teaching about American Indians. And while this framework is built around the social studies, the Living Maya Time bilingual website that our presenter Isabel will share with you this evening is not limited only to the subject of social studies. And I notice so many of you are coming from different subject backgrounds and so forth. In fact, the 8th theme in this guide, Science, Technology, and Society, really connects with STEM very well. I should also mention that these essential understandings are available in Spanish. And so Bert has put both of those links in for you. And for those of you that may be teaching a different subject, STEM stands for Science, Technology, Engineering, and Mathematics. So now I'd like to present to you Dr. Isabel Hawkins, the leader of our session today. Isabel is an astronomer and project director of the Exploratorium Museum in San Francisco and a consultant to Nmei. In fact, she wrote much of this website that you see pictured here, and that will be shared in our chat this evening. It's a fantastic bilingual website that she, I think, is very thrilled to share with you tonight, because her passion is really to work with teachers, students, and the general public to broaden participation in STEM. She was born and grew up in Cordoba, Argentina, and she loves to dance salsa and bachata. Welcome, Isabel, and bienvenidos to everyone. Thank you.
Thank you so much, Renee. Hello, everyone. I'm delighted to be here. I want to acknowledge that I am on the traditional lands of the Saklan Coast Miwok here in California, and that it's a great pleasure for me to be able to share a little bit about this online resource that we created a few years ago now. The topics today are going to focus on the Maya, particularly their knowledge of astronomy and Maya math. I'm going to share with you how the Maya for many generations have used solar observations, knowledge of the moon, the stars, and their calendars to predict and track the seasons and plan agriculture and ceremonies. I'm also going to show you a fun outdoor activity that I did earlier today using simple materials that you can find from around the house, and you can do this with your students to mark the equinox that is coming up on March 20th. Now, if you remember back on February 2nd on Groundhog Day, Phil, the groundhog, saw its own shadow. And so the prediction was that we would have 6 more weeks of winter. And I think that that came true, that's for sure. We're all pretty much freezing all around North America right now. But we are all looking forward to spring. So we have that coming up with the March 20th equinox. Now, this multimedia resource was created collaboratively, so I really would like to acknowledge all my colleagues at the Nmei, at the Smithsonian Latino Center, also a group called Promedios, Chiapas Media Project in Mexico, and Interactive Knowledge, who played key roles in the development of this resource. And in here in this image, you see featured my excellent friends and colleagues. So I would especially like to thank my Maya collaborators from Mexico and Guatemala, who are the co-creators of the Living Maya Time resource. From left to right, we have Alonso Mendez from Chiapas, Maria Avila Vera from the Yucatan, Roberto Pos Perez and his entire family from Sunil and Quetzaltenango in Guatemala, and Pepe Huchim, who is director of the Uxmal Archaeological Site. Without their knowledge and facilitation of many connections with Maya communities, this work would not have been possible. The resource also has 4 lesson plans for grades 5 to 8, and I want to point them out to you since the majority of our audience today are teachers. We have a bingo-like game for younger students called Loteria. We have a Maya multiplication for upper grades, which is an extension of the interactive tool we're going to show today. Observing shadows, which in a way is very much like the activity that we're going to demonstrate outdoors, the one that I mentioned earlier that will focus on the equinox, and an astronomy lesson that connects horizon observations to Earth revolution around the sun. So note that the website has that more advanced Maya multiplication lesson that you can use to dig deeper into Maya mathematics, which is a really fun activity as well. Now, one of the common misconceptions about the Maya is that the descendants of the civilization that built the Great Pyramids is no longer here. So if we go to the next image, please. We can see that the Maya are a vibrant community. There's more than 7 million Maya that still live in Mesoamerica today and from around the world. And so now we're going to watch a video about Maya people and their living legacy of astronomy, calendars, and how their knowledge is alive today.
People sometimes ask me about my Maya heritage, which is very diverse. More than 6 million Maya currently live in Mesoamerica, including my country of Guatemala and large areas of southern Mexico, Belize, Honduras, and El Salvador. We speak more than 30 Mayan languages. Despite differences, words like sun, time, mother, house, and corn are almost identical to the ear, even if spoken in other Mayan tongues. This is because our languages share a common linguistic origin, and because these words convey the very essence of our culture. This includes our relationship with corn, along with the importance of family, respect for our elders, and the fact that we, the Maya, have always been keen observers of the skies. Keeping track of the movements of the sun and the seasons enabled my ancestors to develop one of the most accurate calendar systems ever invented. Knowledge of the sky is still strong in farming communities, and my grandfather observes the sun and the stars to know when to plant. My people also keep an accurate count of the days in our sacred calendar in order to time rituals and celebrations. My ancestors developed a writing system of hieroglyphs, invented the mathematical concept of zero, and built great cities like Uxmal, Palenque, Tikal, Copan, and Chichen Itza. These cities have buildings that were constructed to align with the sun, moon, and the stars. We don't know why the great cities of the past were abandoned. Overuse of natural resources, war, drought, disease, as well as contradictory and counterproductive human behaviors are all likely to have contributed to the decline of our old splendor. By the time the Spanish reached our land in the 1500s, Maya people had already left the great cities. Despite the oppression by the Spanish invaders, we have endured. Today, we grow our corn as we have done for thousands of years. We weave our traditional clothes with ancient designs that reflect star patterns and our intimate relationship with nature. And we use our sacred calendar for the well-being of our communities. We are active participants of the world. We are teachers, doctors, archaeologists, web designers, calendar day keepers, and more. Our culture is being preserved through language, tradition, and a deep connection with the land and the sky.
Well, as you saw, the Maya were and continue to be great caretakers of their culture and their knowledge. And in particular, I want to point out that they are and have always been and continue to be expert calendar keepers. Now, in here we see an image that shows a representation of just two of the many calendars that the Maya manage to this day. The inner wheel is a 9-month calendar called a tzolkin or cholkik that is used to time important ceremonies. And the outer wheel, the one in brown, is called the hab, and it's used to time agricultural cycles. Now, these are just two of the more than 20 Maya calendars that are in use today in rural communities, especially in Guatemala. And in the Living Maya Time website, we showcase 4 such calendars. There's an entire section dedicated to these calendars, including a tool that you can use to convert between dates in our commonly used Gregorian calendar, like, for example, your birthday. If you wanted to see when it falls on the Mayan calendar, you can do that. And why is it that we need calendars? I mean, now we're talking also about seasons, about the changing temperatures as we approach the equinox. Why do we need calendars, and how can we design them to keep accurate track of time? Now, watching and tracking the sun and the stars helps us understand seasons. It also helps us predict critical dates that are tied to agriculture, ceremonies, including important anniversaries. We can build calendars based on the motions of the stars. And most of us are probably familiar with the fact that as the Earth travels around the sun, we experience seasonal change in what are called solstices and equinoxes, which are times that delimit the seasons. Now, the word solstice comes from Latin, and it means sun stands still. And equinox implies equal length of day and night. Now, if you had no watch, your digital calendar or even your paper calendar, how could you be able to measure the passage of time throughout the year and when seasons are about to happen? And in particular, how could you predict them so that you could plan your activities, and your agricultural cycles. Now, if you go outside every day and watch the sun rise in the east, this is a little simulation that we're going to do today, you will notice that the point of sunrise shifts each day, and the spot where the sun rises on the horizon in this image is actually moving north. In the northern hemisphere, as the summer solstice approaches, the sun rises farther north each day until it stands still, rising on the same spot for 4 days in a row. And this will be the time of the summer solstice, or June 21st. Then, reversing its path, the point of sunrise will actually shift along the horizon back to where it began when it goes to its north, to its southern extreme. And this will happen 6 months later, with the sun rising on the same spot furthest south for 4 days in a row. This is the winter solstice in the northern hemisphere around December 21st. And halfway in between the two solstices, the sun is marking the equinoxes in March and September. Now, you can actually do this observation yourself, one complete cycle taking 365.25 days. And we can use this type of observation of the movement of the sun as it rises on a different spot on the horizon to measure the passage of time in a year without using a clock. Now, the horizon features themselves can help you as an astronomer to predict when the equinoxes and solstices will happen. Now, you can do also fun observations to try and figure out the passage of time during a single day using and tracking shadows. And that is the activity that I did outside. So we can do this outdoor experiment to measure the passage of time during the day and use shadows to identify when noon occurs, which is when the sun will be highest in the sky. And you can also use shadows to identify cardinal directions, east, south, west, and north. Now let's watch a video that I took earlier showing how we can use household materials and measure time without using a clock during a day. And then in a few minutes, we'll go outside again and I'll show you a subsequent video when I went out to check my, my sundial. So let's watch the video.
Why do I need a trash can? It's my trash can protector because cars come through here. So I also have a sign, please do not disturb. So I got my plunger. This is my Sundial Plunger. And as you can see, it's casting a lovely shadow. It's about 10:15 a.m. And I'm going to take my handy dandy tape and I'm going to tape it up. Cover the shadow. So I can approximately, it's around there. I cut it. Okay, then I'm going to fold the end so it's kind of as precise as we can get it. And then I come over here and look at the end of the shadow. Right there. And then I tape it up. Okay. So this is shadow. Whoops, looks already moved. Shadow number 1. See, this takes some doing. So you want the shadow to be right in the middle of the tape, right? Okay, there we go. See how the shadow is right in the middle of the tape? Perfect. My 10 o'clock shadow right there. And now I'm going to put my sign here so that nobody will disturb this. I'm going to put it here so that we don't ruin our little fan of shadow that's going to come this way. And hopefully nobody will touch it. And nobody does, because who wants to touch a plunger, right? Nobody's going to touch a plunger, so there we go. My garbage can protector. Done.
So as you can see, my neighbors think that I'm crazy because I'm always out there with my plunger sundial, and they're always saying, an astronomy experiment, what's that about? Now, the cool thing about this is that you can, after you tape the first shadow, you can make a prediction about what's going to happen. So I'd like you right now to make a prediction about what's going to happen to this shadow as the day goes by. And I want you to write your predictions on the chat. So for example, you might want to think about what will the shadow move towards, or how long will it be, or what angle will it cast the next time that you go outside. And then later on, we're going to go outside in a few minutes, and we're going to redo this experiment and see how you did with your predictions. This is a really fun activity you can do with your students. Now let's focus back on the Maya and what tools they use to measure time. Now it turns out that the choice of tools and what's important to measure in terms of time and season depends on your latitude and your landscape. Here's a map of Mesoamerica, where the Maya have been living for thousands of years. Now Mesoamerica contains southern Mexico, Guatemala, Belize, Honduras, and El Salvador. And the region is located within the tropics between latitudes 14 and 22 degrees north. This region is north of the equator and south of the Tropic of Cancer. Now, in the land of the Maya, there are 2 distinct seasons, not 4, as most of us experience in North America. In Mesoamerica, the equinoxes in March and September divide the year into 6 months of rain and 6 months of dry season. So for the Maya, it's actually the equinoxes in this area of the lowland region of the Maya that are important to measure and keep track of time. And these markers, the equinox markers, are even more important than the solstices. Now, some of you may recognize this beautiful place, this aerial view of the ancestral Maya city of Chichen Itza in the Yucatan Peninsula in Mexico, which flourished between 950 and 1200 CE. Now, if you have been there, like I have been there many, many times, I couldn't help but notice that the landscape has no mountains and it's very flat. The horizon has no distinctive features. It looks like a sea of jungle. Now, remember our earlier simulation that showed the little yellow ball as the sun moving along the horizon back and forth? Now, this is a common technique that many humans have used to measure the yearly passage of time and to predict the seasons. But if your horizon looks like this, like an ocean of jungle, like what we see in this image, it is pretty impossible for you to use this observation technique as a marker for the year. You cannot make accurate predictions of the seasons. So if you have no mountains, what did the Maya do? They built pyramids. Basically, they created their own mountains. And as a matter of fact, in the Yucatec Mayan language, the word for pyramid is Huitz, which also means mountain. So the key takeaway message here is that the tools that people use and how people measure the passage of time and the seasons depends on where you live on the earth. And it has everything to do with what your landscape looks like and what your latitude, where you are located in terms of latitude. Now, the Maya built tools and scientific processes that are best suited to their particular local environment. Now, we're going to now watch a video that you can find in the Living Maya Time website. The website here has, as you can see, has a whole section on the Maya and the sun, corn, sun and the calendar, and then the Maya math game that we're going to do later on. So now let's watch the video that will actually show you the relationship between the Maya and the sun.
My Maya ancestors built pyramids and other buildings to record solar alignments at key times of the year. The equinoxes, when day and night are of equal length, mark the transitions between the rainy and dry seasons in the Yucatan. The equinoxes remind us in March that it is time to prepare our cornfields for planting, and in September we need to get ready for the harvest. Our ancestors built temples to honor the sun. The Great Pyramid at Chichen Itza has 4 staircases with 91 steps each, plus a temple on top. The sum total of these steps, plus the temple, equals 365, which is a reference to the number of days in a solar year. During the equinoxes, a fascinating thing happens when triangles of light and shadow appear on the side of the pyramid. After the last triangle takes shape, the sun shines on a giant serpent's head carved from stone at the bottom of the staircase. This entire effect resembles a snake slithering down the pyramid. Our grandparents tell us that this snake is Kukulkan, the feathered serpent, the slithering snake of light that brings the energy of the sun to the earth for planting. At sunrise in the ancient city of Tsibilchaltun, the sun shines through the main portal, transforming the building into the shining face of the sun. In our tropical homelands, the sun can be seen directly overhead twice a year, marking an important event that astronomers call the Zenith Passage. When the sun is at the zenith, the shadows of vertical objects disappear. The Zenith Passage was tracked by using solar alignments with buildings and other structures in ancient Maya cities. At Uxmal, the Zenith Passage can be observed by watching the shadows of the vertical monuments disappear at midday. At Chichen Itza, on the day of the Zenith Passage, the sun sets behind the great ball court in precise alignment with the Chacmol statue. The opposite of the zenith is a Nader passage of the sun, when the sun is directly underneath us at midnight. This astronomical event was also known to our ancestors. In Palenque, the Nader passage is marked by the alignment of architectural features with the sun at sunrise and sunset on that specific day. In the land of the oldest Maya cities, the sun is at the Nader, or directly underneath, in early November. It is no coincidence that Day of the Dead happens then too, because this is when the sun is visiting with our ancestors in the underworld. Maya astronomy is thus recorded in our ancient buildings and lives through the traditions that are still practiced today in our homelands.
Thank you so much. I mean, I think that one of the key messages from this video is the importance of the equinox in the land of the Maya in the context of agriculture and ceremonies. But also the video showed us that in this particular area of the world, there are two positions of the sun that only take place within the tropics, and that is between 23.5 degrees north and 23.5 degrees south, what astronomers call the Zenith and Nader passages of the sun. Zenith being the point directly overhead at noon, and 180 degrees opposite the zenith would be the Nader passage of the sun, in which the sun will be directly underneath at midnight. Now, in our northern hemisphere latitudes in the US, we do not experience these solar positions since our sun is always seen south of zenith for us. So this is only a phenomenon that takes place in within the tropics or in the land of the Maya. Now, it's time for us to go outside and check our sundial again, our plunger sundial, and then we will see what happens. And then I'm going to check with some of your predictions and see how we did.
Okay, so here we're getting close to noontime, and I'm gonna do the other one. It's about like that much. I'm gonna turn this over, and here we go. Now, what do you notice? Change in both direction and length. Okay, that's it.
So basically, I can see from the chat, it says super cool activity. I have to go find a plunger long enough to go above the snow. So you can wait a little bit. And then you can actually use a stick. You can like cut a broomstick and just plant it on your snow if you want to do that. And they could even, if you don't have tape, you could just use, for example, a bunch of little leaves or rocks or twigs to mark the shadow. Some of you are saying that the shadow would get longer. Others said that the shadow would move east and become shorter. That's exactly right. So one of you said that that prediction, and then that was precisely what's going to happen. So thank you. Thank you for all your predictions. And it's really fun to also ask that same question of your students. And so let's see, I went outside one more time, and we're going to see the last video in this sequence.
The shadow came in, but here I can see the tip of the stick. So I'm just going to put the tip right there. Oh, and look, there's a little bit of a trace of a shadow right there. Yay. So next time I'm going to plan this better and put this, there we go.
I didn't account for the trees.
Oops, there it is. There it is. See, you can see the shadow right there. Okay. Awesome. Okay. So that's how you would do it. And then you would do that whenever you want to come out, even every few minutes, because the shadow moves very fast. And when you get the shortest tape will be pointing in true north-south direction, and that's solar noon.
That's great. So, and the main thing is just to encourage your students to go out as often as possible. And the more tapes that you actually place down, the more, the shorter period of time between your experiments when you go outside, the more precise your identification of solar noon and the north-south direction will be. So here's a simple lesson plan that your students can do at home, outside in the playground or backyard, especially when the snow melts. We're going to send you this on email in a few days, but basically, if you don't have a plunger, you can even use like a lamp base with no shade. If you don't have tape, you can use a line of rocks, etc. And for assessment, I really like the students to just simply take a photo and maybe write an essay describing what they did and what they learned. But the main thing is that they can use simple materials, and even they could use their own bodies. If they had a partner to work with, they can use their own shadow as a sundial as well. So it's really fun to be able to even think about your own body as the instrument of observation. So in summary, the Maya used horizon observations by creating their own mountains, the pyramids, or using actual horizons when there are natural features, for example, in the Maya highlands where there are mountains. Or they will use solar alignments with monuments or columns to measure equinoxes, zenith, and nadir. And also they will use shadows like the slithering serpent coming down the side of the pyramid to mark the equinoxes. So it's really amazing to see that your ingenuity and your creativity of what it is that you do to measure the passage of time and solar alignments and predict seasons is really dependent on your particular landscape and on your particular latitude. Now we're going to switch to Maya mathematics. So to do that, I wanted to show you this page of a very old Maya book called the Dresden Codex. It is called the Dresden Codex because that is where it is housed today, in a museum in Dresden, Germany. But this is a Maya book, and is one of only 4 such books that survived the Spanish conquest. All the other ones were burned because they were said to contain the words of the devil. This is a 74-page accordion folded book written on bark paper. And what it records are astronomical tables, incredible detailed knowledge of calendars, and ceremonial information marking important dates. These pages seen here show eclipse tables and symbols for a lunar eclipse on the lower left and a solar eclipse on the middle of the page on the right-hand side. You see that you have half of the symbol in darkness and half of the symbol in light. So it's really depicting an eclipse, or the sun and the moon and the earth in alignment. Now let's notice how the numbers are written. I want you to notice a dot stands for the number 1. A stick or bar stands for the number 5, and a shell stands for the 0. Now, I also would like you to notice that the numbers are actually written vertically in columns, not horizontally like we do. And so the Maya, who were and continue to be expert mathematicians, invented the 0 and did base 20 mathematics, based on the fact that humans have 10 fingers and 10 toes. So we are going to look at Maya math. Let me just go here to my activities, which is also found on the website. I hope you can all see it. Yeah, it looks like it's good. And you can see here, I'm just going to point out that you can find this in the Living Maya Time website. You can see the heading up at the top. And then if you go down to the bottom, we're going to do these practice rounds. So the first round is showcasing how we can use these 3 Maya symbols, the dot, the bar, and the shell, to represent numbers in this little box as prompted by the tool itself. So it says match the numbers with the correct symbol. So it's asking me to represent the number 0. So I'm just going to move this shell over here. Yay, I did it. Great, click this box to close and continue to the next problem. So the tool is very, very self-explanatory, really simple to use. So we're going to just represent a few of the numbers here. Here's the number 1, and then the number 2 will have 2 little dots. And you can have your students practice this until they become familiar with this new way of representing numbers. Number 3, number 4, we're just going to go up to 6, just so that you can see how the bar and the dot work together. And if you were to make a mistake, like right now, if I put the 0, it'll just tell me, oops, no good. So number 5 will be a bar. Great. And number 6 will be a bar and a dot. Awesome. So we're going to show you now, go to round 2, which are the practice rounds that you need to play with so that you become familiar with the tool, and then you can participate in the interactive game. So in here, they're asking us to represent numbers just like we would our Arabic numbers, using a decimal system of ones, tens, and hundreds. So each box here is complete when we put units of 10. So this is a base 10 system. But instead of writing the numbers from left to right, we're just going to write it in the column just to get people more familiarized with this system in which the Maya wrote numbers in columns. So let's see, it's asking us right here to write the number 68. So I'm going to find first the number 8 to put here in the ones column. So that's the number 8 right there. There it is. And I'm going to find the number 6 to put it here in the tens column. So 6 times 10 will be 60. And that's why I have 68 right here. So now let's go to round 3. This is the more challenging one, because in here it says, are you feeling smart? Kind of, more or less. We'll see how we do. But basically in here we have switched to base 20 mathematics. So each one of these boxes is not going to fit 20. So we have the place value of the ones, place value of the 20s, and place value of the 400s. Okay, so now we have to fill 377. So you can just kind of start playing around. You're saying, okay, if this is the columns of the 20s, how many sets of 20s do I put in here that is between 20 and 400, right? So that's kind of the mental mathematics that you have to do. And so let's try and just start folding around. So how many sets of 20s? I wish somebody could give it to me on the chat, but I don't see many people doing this on the chat. So let's just start. I'm just going to start something. 260. That seems too little because this can only go up to 20, you see. So then I need more than that. I need more than this particular 13. So let's put 15 and see what happens. Okay, now I'm getting closer. On the other hand, if I had to put 77 here, I still need more in this column because 77 goes over 20. So let's go some more. So let's try that and see what happens. 320. Now, okay, can I put 57 in here? No, I have to have more. So let's put that. It seems like I have to have more because I would have to have like 30 numbers down there. Okay. Okay, 360. Now that's getting closer because 377 minus 360, I can fit that in there, right? So I only need 17. So let's go find 17. Okay, I succeeded. So that's the kind of manipulation that your students would have to do to be able to represent base 20 numbers. So round 4, it actually gets you to actually do the mathematics. It will showcase Maya addition. And it gives you all the instructions here. You have even like practice sheets, etc. So you'll be able to succeed with this particular tool. And round 5 gives you subtraction. So we have all the basic manipulation of the base 20 mathematics in this wonderful tool. And now we're going to look at how the game works, because the game is really fun. It actually, let's see, I think we need to stop sharing this and go to the game. Oh, there we go. Excellent. So now if we're going to go to the next slide that shows us the game. So the object of the game is really to identify one of three professionals with different professionals. One is called Sihom, the other person is called Ekmoya Chan, and the other person is called Shoptun. And then to reveal the occupations of these three professionals, you get tools. So the goal of the interactive game is for you to reveal who we're talking about, who are we dealing with in this particular challenge. Each clue will allow you to move through 5 challenges, and if you succeed, in the end, you will find out the identity of a contemporary Maya person that will be revealed to us. For example, I chose this particular personage, which is level 2, and it introduces the person. It says, gives you a few of the clues, and then it'll ask me to go through a series of subtraction challenges, so 5 of them. And we can go to the next slide, and you will see that if you do it right, it says, oh, you did a great job, and then it'll give you a first clue. And that will happen 5 times. So at the end, you will have 5 clues. And in here, I kind of showcase the kind of skill or the kind of interaction that this person will have with your students. So if it shows that a person comes and they want to know what you have to say, or the person will ask me for the meaning of the day, of the calendar date when I was born, or the person will be dedicated to looking at the sky. And so then you know that this person, when it gets revealed, is going to be actually a calendar keeper. So the person that gets revealed for us in this particular case, we gave them the Maya name of Ekmoyal Chan, which means star, cloud, sky. So it has all to do with meteorology or with the night sky. And this person is an astronomer and an akich, or a calendar keeper. And then we reveal the actual person, the Maya person today, the contemporary Maya person today, that was used as a model to create this particular challenge. So in here, then the student will be asked to meet Roberto Pos Perez from Guatemala, who's a modern day keeper of the days, or a calendar keeper. So that's a fun thing to do. And also the website will showcase these people working on their day-to-day lives. Like in here, we see Don Roberto, who's my compadre, actually from Sunil, Guatemala, standing in front of his beautiful home that has an amazing mural showcasing the interaction of the 2 Maya calendars that we saw in the wheel earlier in the presentation. Now, the Maya basically use calendars on a day-to-day basis. You can go to a bookstore in Guatemala and actually find printed calendars that use the Maya symbols and Maya mathematics. As you can see in there, you can see some of the bars and dots that represent some of the days. And so these are really very cool, because you can see that this knowledge is alive and it is being used for the benefit of the community even today. Now, calendar keepers come in many ages, backgrounds, genders. And here we see a photograph of Don Roberto Pos Perez and his sister, Vilma Pos Perez. They're both from Sunil, Guatemala, and they're my dear colleagues and friends. And they have been keeping the count of the days for many years. And as a matter of fact, his elders, their grandparents, were also calendar keepers, and some of their descendants are also calendar keepers. This is something that you cannot just learn from school. You basically, it is a gift that is given to you from your ancestral lineage. And the next slide will actually share with you a video that showcases how the Maya today are using their calendars and the count of the days to time ceremonies and to celebrate ceremonies and to celebrate cycles of the calendars that are continuously going on and have been going on for thousands of years in that region. So this particular calendar ceremony celebrates the culmination of the 260-day cycle of a calendar called the Cholkij or Tzolkin, which is a ceremonial calendar.
Huachakifpatz is a ceremony conducted every 260 days by the Quiche Maya people in the highlands of Guatemala. The Huachakifpatz celebrates a new cycle of the Tzolkin Maya sacred calendar. During the Huachakifpatz, a woman or man is initiated as an Ahkij, a calendar keeper who serves as a spiritual and cultural guide to the community. For thousands of years, the highland Maya have gone to caves, to water springs, and to the mountains to pray. These places act as portals that connect the sky, the earth, and the world of the ancestors. This ceremony continues the ancient traditions of the Maya ancestors today.
What's really a great pleasure for me is to share that ceremony with you, is because it is the family of Roberto Pos Perez that they are the community leaders that come together to celebrate the cycle of the Cholkij calendar, and they have been doing that in the same place for many generations. So it was a privilege for some of us, even my colleague Vilma Ortiz, who's going to help me with the Q&A. She was with me during one of the ceremonies, and it's a very special experience, and it's something that makes me recognize the amazing knowledge and expertise in astronomy and mathematics that is still utilized today in the context of calendar keeping in the highlands of Guatemala and also in southern Mexico. So thank you so much. That finishes my formal presentation, and I think that now we can go to the question and answer. And I know that Vilma has been very carefully curating some of your questions, and perhaps you could share some of them with me.
Well, thank you, Isabel. Well, I have a question here related to this last video. Is the calendar keeping passed from generation to generation in families?
Yes, it is. Absolutely. And as a matter of fact, there are several of the younger generation who are becoming Ahkij. And during this ceremony of the 260-day cycle is when new calendar keepers are initiated. And of course, it is an apprenticeship model in which people, younger people learn from their elders, but it's also a gift that comes to them. So it's both, it has a spiritual component as well as a technical component, which is the actual understanding of the cycles.
And are people using Maya math today?
As a matter of fact, I have seen people using Maya math today when they're doing their courses on epigraphy, which is to decipher and decode the Maya glyphs and those, like that calendar page that you saw. There are 4 of these codices still in existence: the Madrid Codex, the Paris Codex, the Dresden Codex, and the Grolier. And they're all used to decipher what the ancestors wanted to write about and their way of living. For example, in the Madrid Codex, the last 10 pages is all about beekeeping and how to take care of the native bees. And it shows calendar dates, rituals, and actual images that shows the bees. And so in one activity that I was involved in Guatemala, where some of my colleagues were hosting a workshop with a very famous epigrapher from Germany, who came and worked with students to decipher some of these writings in the codex. So basically, to be able to do that, you have to use Maya math to be able to understand what the dates are. So definitely Maya math is being used today. And also, maybe around 50 to 100 years ago, in the Yucatan, people were still using grids on the ground with sticks and beans or corn seeds to do their calculations. That's something that has been recorded. So it's an activity that, even though it's not in the day-to-day of the population, is definitely in the younger generation that wants to practice a revitalization of their culture through the epigraphy.
And I have a question here. Do they still practice agriculture coinciding with the lunar ceremonies?
You know, it's interesting that I work with a group of women who did research on the existing knowledge of the moon in several indigenous cultures that included from the American Southwest to Oaxaca to Yucatan and the Maya Highlands. And definitely the Solstice calendar has 9 lunar cycles that are embedded in that calendar, but also there's a lot of knowledge and ceremonies that have to do with eclipses, with key times of the growth of medicinal plants, or when to plant or harvest certain plants, for example, plants that grow above ground or underground. They will be done with the lunar phases. So, and also there was this one elder woman in Guatemala that really inspired me, and she is a very, very elder woman who still remembers certain songs and a drumming that she does to actually sing to the moon, especially when the moon perhaps will be on certain phases, or there might be an eclipse as well.
There's a question here about the proper word to refer to the Maya. And it said, what is the correct term for the Maya people and culture? I have been told that it's Maya when it's referred to the people, and Mayan when you refer to the language and other, when it's referred to the language.
Yeah, the Maya refers to people, you know, the Maya pyramid, Maya Codex, Maya land, Maya practice, Maya ceremony. The only time that you use Mayan is when you're talking about the Mayan Quiche language, the Mayan Yucatec language, or anything having to do with the language. But also I have to say that the word Maya in generally only really applies to people today in the Yucatan. That's what they call themselves, Maya. But if you go to other places like, you know, in Guatemala, they will say, I am Quiche, or I am Mam, or I am Pocomchi, or I am Cachiquel. They don't say I'm necessarily Maya first. They just put their particular cultural expression first, which is also their language. So I always ask people, how would you like to be called yourself, so that they tell me how I need to refer to them. That is actually the best way, is always to ask someone, how would you like me to refer to you?
Is there any movement to bring those the books that you were referring, the codices back, the sacred books back to their native lands?
I don't know of any particular movement on an official channel, which I'm sure would have to happen from the various countries. Also, like, where do you bring it to which country? Since you have so many different countries in which Maya people live, where are those books going to reside? That's another question too, because there are so many political boundaries that in the past were not so clear and so sharp, let's say. But you know, from my perspective, I think it would be amazing to have those books returned, at least returned somewhere in Latin America, within the land of the Maya. But you know, that is also the case of so many resources, like at the British Museum, for example. There's so many Maya stelae and beautiful monuments that are in the British Museum that should go back to Yaxchilan, for example, that should go back to Naranjo. So many of the pottery, the jewelry, you know, the relics and tombs have been taken away and put in areas that are not the rightful owners of those materials and cultural material, and sometimes in the form of books, or sometimes in the form of artistic expression.
Yes, the question is, what does Maya means?
Maya is the ethnic group of the people in Mesoamerica that lived in that particular time. So, for example, the classic period of the Maya is from 250 to 900 CE. But of course, there's a pre-classic period, and then there's a post-classic period, and of course, there's a current period. So for thousands of years, the Maya have lived there. But because they have different linguistic languages, different languages depending on the area, they call themselves perhaps Chichen Maya or Pocomchi Maya or Mam Maya, but they're all from the same ethnic group.
And somebody wants to know if there's a Mayan cultural museum.
Yeah, there's a wonderful museum that actually you, Vilma, you and I visited in the Yucatan. It's called the Gran Museo de la Cultura Maya in the Yucatan. There's also wonderful museums in Guatemala. There's the Popol Vuh or the Ixchel Museum or the Cultural Museum in Guatemala City. But of course, there's kind of the same issues, right? The same issues as we discussed with the codices, that many of the artifacts and the people that put those artifacts in there, most of them were not Maya. So they were taken from Maya sites and put there. But there isn't, a concerted effort to figure out how can these objects live as close to their point of origin as possible and still be preserved for future generations. So that's something that needs to happen through a dialogue between the living Maya cultures today and the curators of those objects.
Okay, going back to agriculture, did the Maya use math to plant three-sister garden? So you mentioned bean and corn. Squash would be the last.
Yes.
Awesome.
The Maya still plant Three Sisters gardens today. So the corn serves as the stalk for the beans to climb to. And of course, the corn takes the nitrogen. The beans, working with the local bacteria, will restore the nitrogen. And then the squash will actually serve to preserve moisture and keep weeds from taking over the milpa or the traditional corn plot.
There was a question about the end of the calendar, of the Maya calendar, if it had an end.
So there's an entire section in the Living Maya Time website that talks about the perspective of Maya people, contemporary Maya people, about the end of the calendar that happened, the 13 Baktun, or the 5,200 year span that ended on December 21st of 2012. And of course, a new cycle began. So we are now on a new long count Maya cycle. So if you want to hear the perspective of Maya people themselves, there are 8 videos in there that tell you what an end of a calendar cycle means to them. But basically, just from the perspective of a cyclical worldview, is a beginning and an end, and a beginning and an end. It continues.
But there are also 2 more calendars. So the calendar, you have the sacred calendar that restarts every 120 days. And
there's the Cholki calendar restarts every 260 days. So it's 13 numbers times 20 days. And then there's another calendar, the Ab, that runs 365 days. And then there's the confluence of those 2 that runs every 52 Habs, or 52 years. And then there's a long count calendar that is more than 5,000 years in span. So those are just 4 of the more than 20 calendars that the Maya manage today.
Right. Let me see. Considering the similarities in culture, language, science, and math, can you discuss African influence on Latin America and pre-Columbus?
Well, as we know, Africans were brought in as slaves to the Caribbean primarily, but also spread to many regions in Latin America and North America. For example, in Guatemala, there's an area near Belize in which the Garifuna people have their own language, and they have developed their own understanding of living in that land. So absolutely, African knowledge has been mestizaje, has been mixed together with other cultures, including the Spanish colonizers and the existing indigenous people of the area before the Spanish came. And of course, after the African cultures came, it all became one integrated and synergistically working set of cultures.
I think somebody's asking how to say solstice and equinox in Maya. Do you know?
Yeah, I know how to say it in Yucatec Mayan. See, I'm using the right way of saying Yucatec Mayan. So to say solstice, which is when the sun stands still at the end of this journey along the horizon back and forth, you say shul bech-in, or the end of the road of the sun. And to say equinox, you say lak et in yetel akab, which means equal day and night, literally.
So and one question is, how do I bring this into my classroom, this information into my classroom?
So I really recommend that you take some time to look at the Living Maya Time website. And because it is fully bilingual, because it has so many wonderful multimedia resources, because more than 40 Maya curators helped us in terms of bringing content to the website. And it reflects their voice in so many different ways. So you can find lots of beautiful imagery, you can find activities, you can find lesson plans, videos, and a lot of tools like the one about being able to convert Gregorian calendar dates into the long count Maya calendar. You can also find an interactive tool in which you can actually decipher some glyphs of one stela that actually marked the end of the long count calendar in 2012. You have that Maya interactive. So I really recommend that you start there. And then many of the lessons there have alignments to the standards so that you can implement them into your classroom. And don't forget to also ask your students to become the instrument of observation and go outside and notice their shadow and how much they will learn just by doing that systematically.
Isabel, everyone, I just want to thank you so much for the program this evening. I hope that it was as illuminating for everyone else as it is for me. Every time I learn something new from you. And I think that not only is your time and expertise a real gift to all of the teachers, but really seeing all this indigenous knowledge. I mean, we sort of, put the sun at the tip of the pyramid, so to speak, in terms of the depth of knowledge of indigenous science and astronomy. And so I just thank you truly for this presentation.
You're very welcome.
Thank you, Isabel. And I want to thank everybody behind the scenes as well who makes these programs possible. It truly is a team effort. And so want to acknowledge all of the people who make this happen that are in the wings right now. And also to, share with all of the teachers that we're really with you right now. We know that a lot of people are struggling and that we're thinking of you and in solidarity with you as you really work to educate our next generation. So we appreciate all of you very much. I also wanted to share a few upcoming opportunities with you through Native Knowledge 360, our education initiative. First, we have a Living Earth teach-in. Really thrilled about this program. It'll actually be on the equinox, so March 20th. Mark your calendars. It will be about traditional foods and how these traditional foods sustain our bodies and our spirits. So we'll have a keynote and a panel and an interactive workshop with one of our educators to share more of our NK360 resources you can use right in your classroom. Second, I want to draw your attention to Math in Action, Maya Numbers, which is a new virtual field trip that we are offering. So we have both some links in the chat to register for those programs, and we encourage you to just continue to participate with us. Again, muchísimas gracias por todo. Thank you everyone so much for joining us tonight. Good evening.
Thank you.